All right. So today we are talking about Gibbs free energy. Okay. Now there is nothing different between Gibbs free energy, the entropy, and the enthalpy in terms of if you're dealing with only Gibbs free energy, it is still the delta G naught of the entire event is equal to the delta G of the products minus the delta G of the, I don't know why I wrote of the reactants. Okay, with all three of these energies here, it is always going to be products minus reactants. It's the sums too, I forgot to put that in. The sum of the products minus the sum of the reactants. Okay, so this equation, you could substitute the G for an H, you could substitute the G for an S, and it would still work. Okay, now when we're dealing with an event that you don't necessarily know the delta G of the products or the delta G of the reactants, but you do know the enthalpy and the entropy, we use this equation. Delta G naught is equal to the delta H naught minus the temperature in Kelvin times the delta S naught. Okay, and remember that naught, that 0, means STP in 1 mole. Okay, we are at 1 atmosphere, 1 mole, and 273 Kelvin. Okay, so that's that. Now it changes with temperature then. Okay, the event can change with temperature. An event that was not spontaneous at room temperature could be spontaneous at a different temperature. Okay, that is why that T is in there. Now, this Gibbs free energy is the denotion of if the delta G is less than 0, okay, if it's a negative delta G, that means the event is spontaneous. Okay, we've heard this before, I'm sure. Okay, if delta G is less than 0, that means the event is spontaneous. That means it will happen without any pushing. It will happen without any outside forces pushing it in one direction or another. Okay, that does not mean it is fast. Okay, doesn't mean fast. Okay, just because it will happen spontaneously does not mean it will happen fast. Like we said, rusting, that is spontaneous. Okay, it happens without any push forward. Okay, but it takes a long time for stuff to become rusty-ing. Just notice that. Rusting happens without any push, but it takes a long time. Okay, so it is a spontaneous event that is very slow. Okay, you can have spontaneous events that are fast, but just because it is spontaneous does not mean that it is a fast event. And so if the delta G is greater than 0, that means it is non-spontaneous. Okay, it requires something else to push that reaction forward. A lot of times that means a catalyst. A lot of times that means increasing the temperature at which that event happens, and that will lead toward a spontaneous event. Okay, so that means there is a very important table that we need to look at. Okay, this table will help us determine if an event is spontaneous or not. Okay, we've got delta H delta S symbol and delta G. Okay, so this is delta H, not delta S, not symbol, and delta G favored. Okay, so if you have a delta H that is greater than 0, I believe that's, yeah, greater than 0, a delta S that is, sorry, a delta H that is less than 0, a delta S that is greater than 0, depending, so if, that's the symbol, so we just wrote, so less than 0 for H, greater than 0 for S, that's what the symbols mean, and then that means the delta G is favored at all temperatures. Okay, that means it's spontaneous at all temperatures. Okay, if the delta S is greater than the delta H, then it doesn't matter what temperature you're at, you're always going to have a negative number, right? Because the temperature is in Kelvin, it cannot go negative, and so you're always going to have a spontaneous event in this case. Okay. Now, if the delta H is greater than 0, greater than 0, delta S is less than 0, so that means it is greater than less than. That means the it is not spontaneous ever. Not spontaneous. Okay, so if we have a negative S value, a negative entropy value, and a positive entropy value, then, enthalpy value, that means this equation will never be positive. It doesn't matter what the temperature is. It will never be a negative G. So that means it will never be spontaneous. Oh, goodness. Bless me. Whew. All right. I think we have 2 more. Yeah. So, greater than 0. Greater than 0. So both greater than 0. It depends only at high temperatures will this be a spontaneous reaction. Okay, both the H here and the S are greater than 0, so that means they're positive. So at both positive S and positive H, then we need a high temperature for the right side of this equation to become negative. Okay, so that event will only happen at high temperatures. And finally, if they are both negative, this will only happen at low temperatures. Okay, so if they are both negative, you want the magnitude of the negative H to be higher than the magnitude of the now positive right side here. Because if you have a negative S, if you're minusing a negative S, then it's going to become positive. And so you want this number to be very, very low. Okay. So maybe, yeah, we'll leave it, but this can also be, I'll put it in red here. So negative, positive, always spontaneous. Okay, positive, negative, never non-spawn. Okay, and then positive, positive, only high, and then negative, negative, only low. Okay, so that is that. That table will help you determine whether an event is spontaneous, whether it is not spontaneous. Okay. Okay, so that is all I have for today's video. In the next video, we're going to be associating Gibbs free energy and our equilibrium talk. Okay, so we'll relate Gibbs free energy to equilibrium because this is all in terms of reversible reactions. Okay, stay healthy, good luck studying, and email me if you have any questions.